The marks in an examination X are normally distributed with a mean mu and a standard deviation sigma. It is known that the probability that X is less than 22 is equal to 0.3085, and the probability that X is greater than 25 is 0.4013. Find the mean and the standard deviation, and it says the top 10% of the students receive a distinction. What is the minimum grade needed for a distinction correct to 1 decimal place? Okay, so what's important in here is that the X can be standardized by taking away the mean and dividing by the standard deviation to get what you know as the standard normal variable, Z, which is for a normal distribution with a mean of 0 and standard deviation of 1. To destandardize, you need to multiply sigma Z plus mu is equal to X. Right, if we look at what we got here, we've got 22, we've got an area here of 0.3085. It's always good to draw a diagram. I mean, this area here corresponds with 22. What we need to do is find the value of Z that corresponds with this value here. And in the upper bound here, with more than 25, we've got an area here of 0.4013. It goes with that value X. We need to find the value of Z that goes with it. And then we can set up two simultaneous equations and solve it. Okay, so we'll need to do phi to the minus 1 of 0.3085 for the standard normal variable. Now, there are several ways of doing that using the graphics calculator. So if you first of all go to statistics mode and select distribution, which is F5, okay, and then select normal, which is F1, and inverse normal, which is F3. We want a variable, okay, we'll go for the left tail, and in the first case we want the area to be 0.3085, enter. We want the standard deviation to be 1, enter, because we look at the standard normal variable, and the mean to be 0. That will give me the value that I want, which is 0.5001. Okay, that's the value of Z that corresponds with that. The problem with this is storing this so that I can use it again. So another way of using the standard normal variable is, in fact, to go to the run matrix menu number 1. Okay, let's just delete what we have there. Right? So we'll delete or F2, F1, so we'll start with a blank page here. Okay, so we've got to remember the order that you're going to put things in. Okay, so first of all, go option. You want to do statistics, which is F5, and distribution, which is F3, and normal, so there's quite a lot to remember there. And then F3 for inverse normal. Right, the parameters are the area, 0.3085. Okay, you have to put a comma. Now, the interesting thing is you put the standard deviation next. And we're looking at the standard normal variable, so it's 1. And then the mean. It seems a bit strange to me, but that's the way it is. And press enter and see we get that same value. And then if we now press shift answer and the arrow button here, store it in a menu and a memory, so we'll put it in alpha A, enter, we can use it again, and then we can repeat the process for the other value, but that was in the upper tail, so we will need to do 1 minus the value, which is 0.4013, comma, 1 for the standard deviation, comma, and 0 for the mean. We'll close that off. That will give you that value. It seems a reasonable value. Again, we'll store it. So shift answer arrow, and we'll put that in alpha B. Enter. Okay, so we'll exit that for a minute. Okay, so just write down what we found. So we found those two values. So I've shown you two different ways of doing that. The reason for doing it the second way is that we can bring that up again in a different menu. That's 0, and then we got the Z values which correspond. Now what we need to do is use this and set up simultaneous equations. So it's going to be sigma my value of Z, so minus 5.00 times sigma plus mu is equal to 22. Okay, and the other one will be 0.249983 sigma plus mu is equal to 25. And we need to solve these simultaneously. If we solve them simultaneously, then we can go back to the calculator and use the simultaneous solver. So that's going to be this one here. So let's just move it down to that one. Okay, and then press enter. So we're an equation, and we're going to do F1. We're going to do two variables. So that'll be F1 again. Okay, we're going to put the values in. So the first one was alpha A. You can see it's put the value in. Okay, B will be 1, and the value that went for that was 22. Enter. Okay, and then we put in alpha B. Enter, and we'll put in 1. Okay, so these are the two equations, and 25 went with that. Okay, and then we'll press F1, it will solve and give the value of 4 and 24. So don't forget the first value was the standard deviation, so it'll be 4, and the y value here gives you the mean. Okay, so it's just a way you could do, or you could just do it manually if you wanted to. Okay, so mu will be equal to 24 and sigma will be equal to 4 using our equation simulator. Then it says the top 10% students receive a distinction. We want to find the grade that we need to get that. So we want the probability that x is greater than some value, x is 0.1. And we now know the distribution is 24, as a mean of 24 and a standard deviation of 4. I always like to draw a diagram. So what we want is this value here that gives this top area as 0.1. So we can go back to the calculator to get the value. So go into the calculator. And pressing menu. And we'll go to the stat menu this time. Enter. And we'll go to distribution, which is F5. Okay, normal 1, and we'll do inverse normal. Okay, we can now set the tail for this, which you can't really do with the other one on the other method, as right. Okay, we want the area to be 0.1. Enter. We now have the standard deviation as 4. Enter, and the mean as 24. And that will give me the answer 29.126. Okay, so we're going to get the x is 29.12. So the minimum grade needed is 29.1. Okay, so this has been a video to show you how to find the mean and standard deviation of a normal distribution, and then use that information to do an inverse normal problem. Hope you've understood, and I thank you very much for watching.